Hey everyone! Thanks for joining us for the next session of our RAG Deep Dive series, RAGChat, Adding Speech Input and Output. My name's Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is being recorded. It'll be available to view on demand within 24 to 48 hours, right here on the Microsoft Reactor YouTube channel. With that, I'd love to turn it over to our presenters. Thank you so much for joining us today.
Hello, everyone. Welcome to our RAG Deep Dive series. This is our stream about speech input and speech output. And I am Pamela Fox. I've been on, I think, all the streams, and I'm a Python cloud advocate, which means I help Python developers work with Azure and other Microsoft products. And today I have a special guest.
Hello, folks. I am Enrique. I am a software engineer manager in the search team. Super excited to be with you today and to join you, Pamela, to talk about RAG, which I love.
Awesome. All right. So we're going to hear from Enrique in the last third of today's presentation to talk about VoiceRAG, which will be super fun. So for those of you who are new to this RAG Deep Dive series, we are more than halfway through the series, and all of the previous videos are all recorded on YouTube. So if there's any topics that you missed, you can always catch up. The recordings are there, the slides are there and public. All of the code is open source, so you can catch up on anything. And you can also register for the upcoming streams so that you can find out when they're happening and join us for the live streams as well. So we are, in this series, we are working through the many features of our most popular RAG solution for Azure. And it is in an open source GitHub repository. So we've got the link here, and we'll share that link in the chat. But here I'll open it up, right? So here's our GitHub. Here's our GitHub repo with all the code, all the documentation, right? So it's got everything you need to get it deployed and to customize it for all the different features that you might want. So what we're doing in this series is discussing how everything works in this repo and how you can use it. And also, so it helps anyone who's using this repo, but it also helps anyone who's developing RAG on your own, because we're sharing all this code, right? And the way that we do something in this repo is probably really similar to how you would do it in your own RAG code bases. And, this is just us making sure that we're all sharing everything we learned about how to build great RAG applications. So you can check out the code there. You can also check out a basic demo that just has like the default features in it. So we'll share that URL in the chat too, aka.ms/ragchat-demo. So that's how you can just test it out and see how it works with our sample data and our basic features. But we're also going to be sharing URLs throughout today where you can try out some of the optional features that we're talking about. So today we're going to see about how we can add different forms of speech input and output for this application. We'll start with browser-based speech input and output using freely available browser APIs. Then we'll look at doing Azure Speech API output. And then finally, we'll go to Enrique to talk about how we can do a real-time voice interface with the GPT-4o real-time model, which is really, really cool, really fun. All right. So let's start with talking about browser-based speech input and output. Now, first, I want to give a big shout out to John Aziz, who contributed this feature and saying this is an open source repo. And, a lot of the changes come from Microsoft employees, but also a lot of changes come from the community. And that's really, really awesome when the community says like, really want this feature. Let's just make it happen and send, these really great PRs that have the features. So this feature is contributed by John Aziz, who's an MVP and who does amazing work. So big shout out to John. So here is the RAGChat app with browser-based speech input and output. So we've got a demo deployed that you can try out. So aka.ms/ragchat/bspeech/demo. We'll put that in the docs in the chat. And we also have the docs, and we'll put that URL there. And the docs just show you how you can enable this when you're deploying this repo. So let me go ahead and try the demo so that you can see what it looks like, right? So go to this URL. Is that one? Let's see. All right, I got it. I'm going to do it in Chrome. Okay, so actually I already have it open here. So let me clear this chat. So as you can see, now my speech input area has a microphone. And I'm going to click on this. Say, what does the CEO do? All right, good enough. So it transcribed as I was talking. And now it's going off and trying to answer that question using the documents that happen to be in this Azure AI search index. So in this case, this sample data is basically like documents for a company, like internal HR, employee onboarding documents, that sort of thing. And part of it includes all the job titles in the company and what they do, right? So here we got an answer. Then I can click on this icon here. This is the speech output. And this speech output is also going to come from this browser API. So let's go ahead and listen.
The Chief Executive Officer, CEO, is responsible for providing strategic direction and oversight to the company, ensuring its long-term success and profitability.
Okay, and I'm going to stop it now. It's a long answer. And you'll notice it did sound fairly robotic. It sounds like what we kind of associate as the original text-to-speech voices. But that's all with the free APIs, right? So that's really cool that you can do all of that with free APIs. So let's take a look at how this actually is implemented. So first we have the speech input, which is this little microphone on the input field. So that's using this browser API called the speech recognition API. And that's actually this is a JavaScript class that you would construct in order to use it. So we create this class, we set the language code. So if you know what language your user is using, then you can set the language code so that it has a better time recognizing that person's language. And in our repo, we do actually use the I18 Next library in order to let users set their languages, and also in order just to detect the language code of the browser and just give us a good way of managing languages. So that way we can have UIs that work across languages and not just for English, which is really, really nice. So we set the language code. We say whether we want interim results so that we can actually see the words come a word at a time. We set an event listener for results so that whenever something comes in, we can go ahead and get that event and write out the results to our input field. And then when they click the button, we start listening. Right. So that's that speech recognition that starts. So when they actually do click the buttons, is when we start listening. Now, one thing you'll notice, I'll go back to Chrome and do a new one. Like I'm asking a question about, and then now what happened is that it actually stopped listening. So Chrome, and this is maybe browser dependent, Chrome will stop listening if you pause for too long. And at first you think that feels like buggy, like, oh, why does it just stop listening? But that's kind of good, right? Because the worst thing is if you'd have like an interface that just keeps on listening forever, right? This is like our nightmare with, like home voice assistants. It's like, uh-oh, like they listening to like our private things, right? So Chrome by default, it will stop listening when it hears like a pause of a few seconds, right? So if I wanted to, if I remember what I was going to ask a question, then I would just the whistleblower policy. And I guess I decided to restart the whole field in that case, but you could handle that differently. But I just wanted to point that out because that did surprise me when I was first doing it. I was like, oh, why did it just stop? But that's actually, I think, a nice privacy feature is to automatically stop if it just feels like somebody has just stopped talking. Oh, I see. Luis asked, could it not automatically recognize the language? I don't know if the speech recognition, let me check if the speech recognition API recognizes the language. Certainly, if it doesn't, you can, the browser can do it. So you lang, okay, returns and say, if not specified, this defaults to the HTML lang attribute value or the user agent's language setting if that isn't set either. So if I had, like if I go, I'm in Chrome, so think about it like Chrome settings, languages, right? So you can see my languages, let me make it bigger. We have English here, but I could add a different language like Spanish, and then even make that my default language. And then if I did that, then yes, the speech recognition would default to that. In our case, since we are using this INTN next package already, then we use the INTN next, the logic in order to decide the language, because we do have like an optional language picker where they could override the language if they wanted to pick a different language, right? But INTN next would also just default to the user agent language if it didn't see one set other ways, right? But it also lets you like store cookies and local storage and stuff like that. So yeah, that's a great question. So if you're doing this in a basic app where you don't have any other sort of localization, then I would just, don't set this and just let it default. And that's the best, that would be the best experience. Great question. All right. Okay. So that's our speech recognition. There's a little more code than that, which you can see in speech input.tsx, but that's the basic idea. So let's talk about browser speech input. Like, how well does it work? So the pro is that it is free. That's always great. We love free stuff, right? And it does actually work fairly well. Like it got all of everything I'm saying. What I don't know is like, how well does it work across different languages and accents? So if any of you have tried it out and can share your experience with different languages, dialects, accent, etc., I'm trying it with a fairly I don't want to call standard or default or anything like that, but I'm trying it with an American accent that's either from the East Coast or West Coast with British parents, but it's like somewhat, it's pretty American accent, right? And that's probably what it's been trained on, knowing a lot of this stuff. But I'm hoping that they've also trained it on other accents, since obviously users come in with, from all different countries. So I'd love to know how it works for people from different languages and all that. To hear what that experience is like. Now, the big con for me, especially, is that it doesn't work in all browser and operating system combinations because it actually depends on the browser, including like a piece of software, like a binary that can understand speech. So I'm actually using Chrome today because if I used Edge, I would get an error because it just doesn't work on Edge on a Mac OS. Now, to be fair, most people who are on a Mac don't use Edge. Most people on a Mac are using probably Chrome or Firefox or something. Most people using Edge, I think, are on Windows. But at least at Microsoft, there's a bunch of people using Edge on a Mac. So that's certainly a con, is that it just straight up doesn't work in my default browser. And I have filed an issue with the Edge team. But it's not fixed yet. So I'm just pinging that issue as much as I can. And then also just generally, because it does depend on the browser shipping its own binary with it, then the quality is going to depend on the browser and OS that the user is using. So the user experience can be really, really variable, right? Like my experience in Chrome on Mac would be different from my experience on Edge on Windows, right? Because it would actually be two different packages from the different browser vendors. So that can be hard if you're trying to provide like a really consistent experience. Like you imagine you get user feedback that's like, your speech input didn't work. It didn't understand me. It parsed it all wrong. And then you're like, well, which, OS combination were you like? It would be hard to have a really reliable experience that you could ensure quality control for, right? So it's great that we have this option. It's free. Like it's definitely something that, we should at least consider adding to our applications in order to increase their accessibility. But if you know that you have a large fraction of your user base using speech input, and then you may want to consider, using something that you pay for so that you can have more quality control. Donnie asked, is there so much difference between the different browsers? That's a good question. I can't use Edge on a Mac, so I've only been able to experience the Chrome version. I don't actually know if there's so much difference. I would think that maybe for, I was saying like maybe for my voice, maybe it'd be similar, but maybe for other languages, right? Because that's a lot of times like, like you see the quality evaluations get run on like, English America, English US. But we're trying to build things for like the global audience, right? So that's where quality can start to really differ. So yeah, it's a great question. So that's another great thing to test. Try out on different browser vendors, right? So try out on Chrome, try on Edge, try Firefox, whatever you expect your users to be using, and try it with the languages and voices you expect your users to be using and see. Maybe it's actually pretty similar. But I haven't seen any exact metrics about it. And it's very possible that it's going to be not similar since it's shipping with different software. Okay, so now let's talk about how we do speech output in the browser. So that's using a different API called speech synthesis. And it's window.speech synthesis. It's actually a global on the window. And then you create this speech synthesis utterance and you pass in the text that you want it to say. And then once again, here I set the language code. You could also let it default to the browser. In this case, we're passing it in. You can set the volume, the rate, the pitch. You can also filter and to see what voices it has. I honestly don't know if it even has that many voices. Let's actually try and run this in the browser. Speech synthesis utterance text. Okay, let's see. So we're in Chrome. Let me go to the console. New speech synthesis utterance and hi. And then let me like save that into something. Utter is a good variable name. Okay, utter dot voice. Let's see. So you do voice utter dot get voices. Is this it? Synth dot get voices. Oh, it's window dot speech synthesis. Window dot speech synthesis dot get voices. I'm just trying to see how many voices there are. Oh, there's quite a few actually. 176. Oh, this is cool. All right, so these are all the voices, right? So you can actually see. So that's the thing. If you like, when you know the language code, you can also try and find a good voice that will match language code. So we have our logic will just pick the first one it finds that matches the language code. We've got ones for lots of countries here, lots of European ones. We do have one for Japanese. Yeah, there's quite a range here. So that's cool. Remember, this is in Chrome. So if I ran this in, let's see, in Edge, I'd probably get a different response. So I'm not positive. So, okay. All right. So there we go. We see lots of voices. So we go through the voices and find one that's appropriate for our language code. And then we speak. So whenever they click it, then we just speak, use the speak method in order to speak it. And there we go. So that's the speech output. Now, the pro of this, once again, is that it's free. The con is, as you probably heard, it was very robotic sounding, right? To the point of being maybe kind of painful to listen to, depending if you enjoy listening to that sort of voice. And also the pronunciation quality it's not great, right? It doesn't sound like fluent pronunciation. It sounds like, it knows how to pronounce a certain number of syllables and it's kind of streaming it together, but it doesn't really understand that, how to pronounce words all together. And not as many options of voices. We did just see there were a fair number of options, but there's not as many as we could get with a cloud-based service. So when I heard that, browser speech output, then I really wanted to have a different option there because that robotic voice just really didn't sound very good. So that's why we decided to also then add the Azure speech output. And once again, John Aziz added this. So thank you once again to John for adding this output. And I do see some questions about, what speech services we've tried. So so we added this additional option for Azure speech output. So let's see what that looks like. because this is another really good option to consider having in your application. Yeah, so Paulo asked what speech services that we've tested. So basically, the other thing we're using is Azure Speech only for the output. We're actually not using it for the input yet because I was saying like the input actually does seem pretty good. The output, you can really hear that it doesn't sound great. So we really wanted to have that Azure Speech output option for people who are willing to pay the cost of using a cloud service to generate it. Now, if you have Azure credits, then you don't have to pay a cost. You have it, you're able to use those credits for Azure Speech. So I would definitely be trying out Azure Speech for that. And they've got lots of different APIs. So we're going to be using the text-to-speech API, but they've also got batch APIs. They've got the avatar API where you can get like an avatar with your text. They have a bunch of really cool options. Okay, so for Azure Speech, we have another demo that you can try. And for this one, it only has the output option because we've only enabled Azure Speech as an output option so far. But you can go ahead and try that out. So let's see what that looks like. All right, so I think this is the one. We'll find out soon when I click this play button.
A product manager is responsible for overseeing the product management team, driving product development and marketing strategy, and ensuring the successful launch of new products. A title equals role_library. PDF hashtag page equals 28 class equals subcontainer.
Okay, so I just let you hear the whole first sentence, including the citation. And we do have an issue open that maybe we should drop the citations from what they say when they're reading out loud. So I think we probably need to improve how the citations are sent to the text-to-speech. But as you probably hopefully heard, that was a much more fluent speech output. It was really nice, and everything was pronounced very well, very clear, and just much better than the browser speech output, right? So how does this work? Now, for this Azure Speech output, it's a little different from the browser speech output where you click it and it just instantly does it. For the Azure Speech output, we're delay loading it basically. So what happens is you click that, that sound button, and then we check to see, is it playing now? Okay, if it's not playing yet, then we need to start playing it. And we check to see if we have a audio for that text yet. And if we don't, then we need to go off to the server and generate audio for it. So it's like, okay, if we don't have the audio for it yet, we're going to hit up our backend. Our backend is going to hit up the Azure Speech SDK and tell the Speech SDK, like, hey, generate some audio for this text. The Speech SDK comes back with some MP3 data, and we send that down to the browser, and now the browser can play it. So there is actually a delay. So let me do a new question because I think I already had that one loaded. So if I did this question, so you see that first it's going to generate, first we're going to generate the answer and get back the response for the answer. And then only once the full answer has been generated, and even after that, actually, so it's not going to do anything until we actually click this button. So when I click, you see there's a little kind of looks there. Yeah. So there was briefly a kind of loading indicator, and then it actually did come back pretty fast, but there was a very brief loading indicator, which doesn't happen with the browser speech output. And that loading indicator was it going off to the server, generating that speech and coming back. And it was actually pretty fast, which is nice. This is why we can do this, is because the Azure Speech SDK is pretty fast at this. But it does mean that there is a slight delay. So this is the kind of overall design of how we generate that speech. So we can look at the code a little bit more, right? So this is what the code that gets executed when you press that button, right? So we check to see, do we have the URL already? We can play it. If not, we need to go out and get that speech MP3, and then we can play it. So that goes off to the backend, and this is Python code here. The Python code will connect to the speech SDK. It'll pick a voice. We default to the Andrew, but you can change that voice to any of them. I picked Andrew because it sounded the most neutral to me, and also it supports, I think, the most number of languages. But there's a bunch of different ones you can do that have, kind of different styles and support different ranges of languages, and they're all really, really good. And so then we get back the audio data and we send that back as an audio MP3. And then it comes back to the front end and we actually turn that MP3 data into something called an object URL. And it's a URL that looks like it starts with blob colon. I don't know if you've ever seen those in front end code, but it looks like blob colon. And we can actually use that in audio tags. So we get this blob colon URL based off what came back from our server. And then finally, we can use an HTML audio element. So we're basically constructing an HTML audio element and putting that in our page, and then setting the source of that to the blob URL and then playing it. So that's the whole end-to-end flow for how we play that. So the big point of it is that it is delay loaded. And the interesting thing is that we started off with preloading the audio. So originally, as soon as we finished generating the answer, we would generate a speech MP3 for each of the answers. And the nice thing about that was that you would immediately get to hear the audio, right? There was no waiting period because it was already ready. But the bad thing is, and this was pointed out very quickly in the issue tracker, the bad thing is that you're paying for all of those speech generations, even if they're not used. And so that's obviously can be a big waste of money and also a big waste of, energy and resources, right? So generally we shouldn't spend effort on something that a user isn't going to use, right? So, if we knew that all of our users were using audio like 100% of the time, or if you had even a mode for a user to say like, I always want audio, then it would certainly make sense to preload the audio because you would know that the user really needed it. But in this case, this is like an optional feature that we think maybe some users want. And so we're delay loading to avoid, wasting time generating audio that we don't know if people will want. But this is definitely a consideration that you need to think about depending on why you're adding speech output and input and, what your audience is like. Yeah, so let's see. I see some, so some comments from like Paolo. So Paolo's asking, do you know any studies about how many users or percentage of users are using speech when interacting with an AI assistant or agent? No, I don't, but I would love to see those studies. If anyone's seen any of them, we would have to know. I wonder if we could ask the GitHub Copilot team, because GitHub Copilot does have a voice option here, right? So you can see voice input, and there's also voice output here. So theirs is really similar. So I'll see if they'll share anything about that, because that would be really good to know. I actually used them for a lot of inspiration when I was working on speech input. I do have another, so for speech input specifically, I do have a, I have a blog post that's very specific about how to do the browser stuff. And I have a more minimal repo that you can look at. And there I based the interface entirely on the Copilot code, like their style. So that's so this repo, this is the Vision Quick Start. So it uses both a vision model, but it also sets up speech as input and output using browser. So if you're specifically interested in, how to make a nice interface for speech input output, and you're adding it to a different app, you might also want to check out that repo, because I made basically like a standalone web element that you could embed inside your code. And it has some pretty cool CSS. All right, so then, so Paolo's guessing that a tiny percent of users actually use speech. Yeah, so that's a great question. So I'll see if we can get any stats on that, maybe from the Copilot team or from other Copilot teams. But it's also good to keep in mind is that like adding speech is an accessibility thing, right? So even if only a small percentage of users use speech, you might be enabling a user that would otherwise be unable to use your product, right? And that's why we make products accessible, is because we're enabling people that otherwise just wouldn't be able to use a product whatsoever, right? Because like they're having issues using their fingers or whatever, like their hands, right? So, there's many reasons why somebody might want to need speech. Maybe they're walking around, they're driving, whatever. Not they should do anything while driving, but so even if, and that can make it harder to, sometimes for some people, it's harder to justify accessibility improvements because you're like, oh, it's only a small percentage of the code base. But man, when you get emails from people that are that small percentage who are like, oh, this works for me, you're like, yes, that is why I added. Like, I remember I worked at Khan Academy and got an email from somebody who was going through the computer programming course that I was making. And he sent like 20 different accessibility issues. And even though he was just one person, I went and immediately fixed all of those issues because it was like, I want you to be able to use this course, right? Like, you're clearly dedicated enough to send me, an audit of all of my issues. So so that's something to keep in mind, is that it may be a small percentage, but you're enabling people to use it that otherwise maybe wouldn't be able to use it at all. And also, like, a lot of times maybe you might think like, oh, like only some a small percentage disabled or whatever, like, but there's many kinds of disabilities. There's like chronic disabilities, there's temporary disabilities, and there's situational disabilities, right? And we often don't realize, like, when you think of all those sorts of situations where people need accessibility options, it covers so many things, right? So as like a parent, a lot of times I only have one hand because the other hand has been completely commandeered by my 2-year-old or 5-year-old, or sometimes I have 0 hands because I've got 2 kids, right? So anyway, accessibility spiel. If you can add ways to make your app more accessible, it will help people in ways that you don't realize, and it's always a good thing. All right. And there's a question from India: which file has the code for speech in the solution? So I tried to put the file names in the slides, but I didn't link to the full thing. But generally, there's speech input for the browser speech input, and then there's speech output browser for the browser speech output, and then there's speech output Azure for the Azure speech output. And then also, if you were looking at my, I also have the other one I was linking to. It has a what's called so the one, our main RAG repo uses React and TypeScript. This other example here is similar, except it's using just vanilla JavaScript. So the speech input button is what's called a custom HTML element. And that's something that you can use in any framework. So I was trying to write it in such a way that anybody could easily bring in the speech input and speech output buttons into any framework. So that's just in here. If you're looking for that's browser speech only. So hopefully that gives you lots of options, right? So if you're using our RAG repo, you can just go ahead and enable the browser speech input, Azure speech output, whichever combination you want, and it'll just deploy it for you with those options, and it'll just work. If you're building your own RAGChat or any sort of chat application, any application which has an input field and text field, then you can look at our React components, look at our custom HTML elements, and bring that code into your repo. It's all open license, so please take it and add speech to your repos. All right, so I've been blabbing enough, so we need to get over and talk to Enrique. So here's the thing. Another thing you can say, if your user does need audio all the time, then you might actually want to have a real-time interface where the user can just talk back and forth with audio. And that is what Enrique is going to be talking about.
Thank you, Pamela. Yeah, super interesting. Thanks a lot for all of that. So yeah, I'm gonna talk to you about how can you do real-time RAG with audio, right? So far in the series, you guys have been talking about how to do this over text. A few months ago, the GPT-4o real-time preview model came out, and all of a sudden you could do real-time audio communication with these models, right? It's full duplex, so you can interrupt it. It will pick up the language that you're using like real time. So this is like super, super, super cool, or at least, I love it. As soon as this got released, right, even a bit before that, we're thinking about, okay, that's great, but how can you actually do RAG, right, with this, because it has some nuances. Specifically, how can you do citations? Citations are super important in any RAG application because you need to verify that the data that the model is giving you is actually like good, right? It's not being hallucinated. You can try your best, but it can always happen. So it's important to have that citation. So doing this over voice brings an interesting challenge. How do you do citations over voice? So just keep that in mind. I'm going to show you later how we fixed it. We created a new sample, so it's not the same as the one you've been looking at in the series, but it is compatible with it, and we'll show you at the end how you can really easily, if you have one setup, you can use the other one. You have the links here for the other repo. It'll be super familiar to you if you have looked at the text only one. And we call this pattern, this repo, very original name, VoiceRAG. So I'm actually gonna switch over to a demo. And before we do anything else, I'm gonna show you what this looks like. So I have loaded this app with the same files as the other repo, right? So it knows about data for HR employee benefits, that sort of thing. For Contoso, the same as the other sample, basically. So let's try it out. Does the company employee perks cover scuba diving lessons?
Yes, the company's Employee Perks program covers scuba diving lessons.
What are my options for healthcare plans?
Your healthcare plan options include 1 Northwind Health Plus, comprehensive coverage for medical, vision, dental, prescription drugs, mental health, emergency services, and preventive care. It also offers wellness programs and case and disease management support. 2 Northwind Standard, basic coverage for medical, vision, and dental services, preventive care, and prescription drugs.
Wait, so not all of the plans include emergency care?
That's correct. The Northwind Standard plan does not include coverage for emergency services.
Okay,
whereas...
thank you.
You're welcome.
Vamos a cambiar a español. ¿Están incluidos los exámenes anuales de vista en el programa de salud?
Sí, los exámenes anuales de vista están cubiertos por el programa Northwind Health Plus.
Vale, gracias.
De nada. Si...
All right. So as you saw there, some cool things. Full duplex, you can interrupt the model so it won't finish generating the answer. You can switch the language. You can probably tell I switched to Spanish. Yes, my accent means I am from Spain. You can probably tell. And super cool, as like a non-native English speaker, it's just so cool to talk to my data, which is in English, in Spanish, in my natural, my mother tongue, let's say. I just love it. And the other thing you may have noticed is these little pills pop up as you were getting the answers, as we were getting the answers. These are the citations for the answer that the model was returning to us. And if you click any of this, you can see the chunk of data that it used to generate that answer. So that's how you can get the citations, right? So high level, what the app is doing, and you will be able to do exactly the same thing with your own data if you clone the repo. If you already have it set up with your sample, just clone this repo, set some environment variables, and you pretty much automatically will have real-time audio with your data. We call it like talk to your data. And high level, what we have here is we're getting your input audio using the browser APIs. We're sending that to the GPT-4o real-time preview, that's a mouthful, model to generate the answer. And we're using AI search as the knowledge base to get the data from your knowledge base to the model to generate that answer. And then once the model generates the answer, we're passing that back to the browser. And again, we're using the browser APIs to just literally stream out the audio from the model straight away. So I'm gonna switch to the code so I can show you what that looks like, and I can talk a little bit about the pattern. This is like a high-level architecture diagram. long story short, what we have here is on the left, we have a front end React app. Again, very similar to the other sample if you have used it. Oh, let's restart the code space. Just take like a second. But yeah, this is basically a React app with your typical components, right? There are some nuances about doing audio in the browser and some nuances about the format that the model expects, right? You have to transform the audio using the web audio API to PCM, whatever, lots of audio specifics that, you may be in the business of selling products, not in the business of figuring out the web audio APIs. So we have figured out how to do this, and it is in the repo. You can just go use those components out of the box. It will work with this, so you don't have to worry about it. So this front end uses a library using WebSockets to talk to a middle tier API, which is like the core of this sample of this application. And that middle tier is the thing that will talk to the Azure OpenAI real-time API, as well as to the Azure AI Search service that has the index with your knowledge base to generate the answer. So as you can see, this is like a proxy, and we designed it in a way that's compatible for the most part with the protocol, the real-time API protocol out of the box. There is an extra, say like a new message type for the RAG knowledge base generation, but everything else is pretty much compatible. So you could have your app, build it with the real-time API, delete the proxy, and everything except for RAG will continue working. Another advantage of having this middle tier here is that your client does not have direct access to the real-time API, does not need to have the keys, and it also doesn't have a point of view to the AI search, a line of sight to your AI search. So it's all encapsulated, it can be secure, etc. So that's a high-level overview. Now we're gonna look at some actual code, right? Because I don't know about you, I'm a developer. This is great, show me the code. So the React app, we created a hook called use real time. And this hook will abstract most of the functionality that you need to actually call our proxy and to have a VoiceRAG working. So it gives you a bunch of methods of callbacks, right? Like on WebSocket open, close, etc. The important thing is on received response audio delta. That basically means the model is streaming the answer back to you. That is important. It is not generating the full answer and then giving you the full answer. It is streaming via WebSockets the answer, so that they call this a delta. So as you are receiving the delta, we're saying, okay, if you're receiving the delta, then play the audio to us through the speakers. On received input audio buffer speech started. That means when you detect that the user is speaking, when I start speaking, then stop the audio player, right? Because you're going to interrupt the model and we're going to want to send another piece of audio back. And then on received extension middle tier 2 response, basically the RAG piece of it, right? When you send me the citation, I want to do something with it. So in this case, we're rendering this little pill, but you could do whatever you want with this. That's the gist of it. If you go through this app, which is basically app.tsx, most of the logic is here for when to start the session, when to start recording, when to stop recording, when to reset the audio player. There's a bunch of nuance to how to make the web audio API work well in a scenario like this. So we already figured this out. You can just go and use this and it will work for you. You don't have to worry about it. Again, you could take a look at the use real-time hook to figure out exactly what we're doing. There you go. To figure out exactly what we're doing, right? This is the command to start the session. This is how we are adding the user audio as you start speaking, for example. And you can look at all of this code and basically modify it to do whatever you need to do. And by the way, this is not using any SDK. This is all literally our code talking to our proxy middle tier, right? If you're interested in how to make the browser talk and listen and process all of the audio in the format that it needs to, you can use these hooks, use audio player and use audio recorder. You can look through the code, figure out exactly what we did, how we're doing the buffering, change it if you need to. Otherwise, you can just leverage all of this code, and it will just work for you.
So how is
now,
it so fluent? There's
Mhm.
no pauses. Like it just comes in at the right pace.
That is correct. It comes at the right pace. We do have a little bit of buffering, but very little. For the most part, yeah, you can just play it as it's stream and it works.
So cool.
Yeah, which is pretty cool. Okay. Now moving on to the backend, which is, let's say, where the magic is happening. And I want to take you back to the beginning of my presentation where I told you citations are really important. How the hell do we do this in, how do we do it with real-time audio? So here's the thing. Typically, when you do citations with text RAG, what you do is you tell the prompt, hey, when you find a piece of knowledge, give it back to me, but in brackets, tell me the name of the file where you got it. So you would get in the answer like brackets, employee handbook.pdf, and then the piece of text that you got, right? So the model will be able to tell you, hey, these are the citations that I used. With voice, that doesn't really work because it would return brackets employee handbook.pdf as part of the answer. You don't want to stream that audio, right? You don't want to be, yes, the plan bracket employee handbook.pdf brackets includes whatever. So how do you do that? The way we're doing it is we are using function calling, and we have two different tools. One, to search the knowledge base, which is AI search, so you can get the best results when you're doing RAG. The other one is to report where you got the grounding information. And with these two tools, you can make this happen. I'm gonna read you what the prompt looks like because it is pretty simple. So we're basically saying, hey, you're a helpful assistant, only answer questions based on information, you search in the knowledge base, blah, blah, blah. Accessible with the search tool. So if you need to search the knowledge base, use the search tool. The user is listening to answers with audio. Super important to keep it as short as possible. Something we realized is the real-time models are super chatty. So in the prompt, I would recommend you try to nudge it towards being brief. Otherwise, it will talk and talk and talk. And then this is the key thing. Always use the following step-by-step instructions to respond. And we actually found out if you use this sort of bullet point or number list approach, it's pretty good at instructing the prompt. The model will follow this pretty well compared to not using this. So number one, always use the search tool to check the knowledge base. Number two, always use the report grounding tool to report the source of information from the knowledge base. And then step three, produce an answer. That's short. So that's the gist of it. Now, I want to show you what the implementation of those tools look like. So this is the search one. It's basically search the knowledge base, blah, blah, blah. The implementation of that search tool is basically calling AI search, right? With, making a hybrid search. It's using semantic ranker, so you get the best results. You could also make it use query rewriting. Basically, it's just calling AI search to get the data from your index. And then the second one, which is report grounding, says report use of a source from the knowledge base as part of an answer. Effectively, cite the source. Sources appear in square brackets, blah, blah. Always use this tool to cite sources when responding. Okay. So that is basically, it's looking for, basically the sources of the stuff that you used, right? And that's going to send a message with it. So if we go to our middle tier, which is this RTMT file, and this is the file that's doing all the proxying with the model, right? And for the most part, I told you the API looks the same. We're just sending the same messages back and forth. I'm not going to go through all the code because it's, it's quite a bit. It's not a lot, but it's just too much to do it right now. The important thing is looking at the function calls. If the function call is, Okay, let's take a step back. You ask a question to the model. The model decides, hey, to answer this question based on my prompt, I have to use the search tool to get some data. So it's going to make a function call. It's going to say, hey, I want to do function call search. It's going to come here, and we're going to say, oh, okay, this is actually going towards the server. So let me actually execute that, get the data from AI search, and then pass it back to the model. Now the model is generating that data and realizes, hey, I actually have to use the report grounding tool now. So it will invoke that again, and we will get it here again. I'll be like, oh, actually, this goes to the client. So let me execute it. It's going to get the sources, and then it's going to send it to the client with this new message type that we created called extension middle tier tool response. So from the client, meaning from the React app, you will get two things. You will get the stream of audio. Those are the audio deltas, and you just play that in the speaker, right, using the browser APIs. And you will also get this extension middle tier tool response with your citations. And those, in this case, we're rendering the pills with the citation information. This is basically the gist of what's happening. I want to give a couple of minutes for questions. This is kind of a lot, and I went through most of it. So, take a couple of minutes, see if there's anything you want to ask.
Yeah, we do have a few folks wondering about optimal chunking and formatting when you're making specifically a speech assistant, right? So like in your experience, should we be doing something even more specific than what we're already doing when we're chunking and formatting, like or things to help with pronunciation? Like what could we be doing to optimize things for VoiceRAGs?
From what I have seen, I haven't noticed anything significant. What I have noticed is getting the most relevant chunks is still the most important part, but it's unrelated to the actual audio model. The model itself handles a lot of the complexity of pronunciation and all of this. So, if, for example, if your content is in a specific language, having like a vector store that is optimized for that language is always going to help you get the best results when you're making that query. But that would be the same if you have text data. So as far as I know, nothing specific I would tweak for this, but I would always recommend you run some evaluations on your RAG apps so you can verify this yourself for your use case. And I believe, Pamela, you're going to have some sessions on evaluation down the line, right? So you probably don't want to miss those.
Yeah, that'll be Monday. Though I haven't tried doing evaluations on VoiceRAG specifically because I haven't set up kind of a VoiceRAG evaluation flow. Like the evaluating with multiple modalities gets harder, but you can evaluate retrieval also just independently. But it's interesting when we talk about doing multi-language, right? Because if somebody's you're talking in Spanish or French or English or whatever, and or bringing some like other language like Chinese, Japanese, Korean. And if your original documents are in English, the question is how good are the embedding models at going across languages? I found that they're pretty good, but also there's some weirdness. Like when I do like between Spanish and English, like if I leave off the, like this is for text, but if I like leave off the accent mark, like in like Rey de Leon, it does a better job than if I have an accent mark. So those sort of like things like kind of concern me where it's like, okay, like we do have multi-language support, but like, how can we really get really good multi-language support?
Yeah.
Okay. So there was a comment just about generally like with, using C# when making assistants and agents. And he wasn't asking specifically about VoiceRAG, but I think it's an opportunity to ask, like, can you do this in C#? Like, do you have everything you need in terms of WebSockets and all that?
Oh, yeah, definitely. You could build this in any language, honestly. C# would be great for this as well. Nothing specific here. We're using Python, is going to be, it's going to bring it over. You could build it in C# too. I would say you would just have to rewrite, the proxy in C#, but you can do that easily. using this as a template. And you may want to use semantic kernel for the communication with the index to retrieve the knowledge base. That's going to make your life easier when you're coding it. But yeah, you could do it in C# very well.
Yeah, we do actually have someone that is working on the C# one, because it's been asked in the repo. So if you are looking specifically for C#, we can hopefully have a repo for you soon.
Yeah, it's coming.
Yes. Okay. And what else? Oh, which model is being used for the voice demo? It's
the GPT-4o real-time preview. I forget the specific version. I think it's 2024 10 11 version. But yeah, the model is GPT-4o real-time preview.
Yeah, there just came out a new version last week. Did you deploy with that version, or are you using the old version still?
Old version still.
Okay. Yeah, I deployed with the new version and seems to be working pretty well. But yeah, that was just like one that came out like 2 weeks ago. The biggest issue actually is that I think we still only have 1,000 tokens of capacity for the real-time models, right? Like, is that something that customers can increase them if they do a request, you know?
I don't know. I know there's also a GPT-4o mini real-time preview model that's out, but I haven't played with that one.
Okay. Yeah. Yeah, so definitely try out the different models and the newest versions of models. Like whenever we come out with a new version of the model, it's usually generally better than the old one. So it's always good to keep things updated. We have a question. Does semantic kernel support multi-agents? I don't know. Have you been playing with semantic kernel much? I feel like it does. Yeah, actually, I think it specifically does, because we're, we're coming up with we're going to be doing like an agent hackathon, a little FYI, even though we haven't announced it publicly, but we're all friends here. So we're working on like an agent hackathon, and there we're talking about like, what do you use for your single agent flows and what do you use for your multi-agent flows? And so for multi-agent orchestration, we're talking about semantic kernel for multi-agents as well as AutoGen. Those are two different frameworks that you can use for multi-agent orchestration. So even though I haven't personally used semantic kernel, I'm going to say that yes, it does support multi-agents. Cool. All right. Let's see. Any dates for the agent hack? This is where I get in trouble for revealing stuff. It'll be like in the next few months. So just stay tuned to me, I guess, on social media or Microsoft Reactor. If you subscribe, we will host on Microsoft Reactor again, I believe. So yeah, just stay tuned, and I'll mention it in any streams I have once we have the registration available. It'd be great to have all of you. I'm sure you'll build amazing agents. I haven't even really truly built an agent myself, so maybe I'll get to build some agents. Are there still restrictions for making our own neural voice? I wanted to, but needed to fulfill all these forms. So I think that's Paulo is talking about the I assume Paulo is talking about the custom neural voice for Azure Speech, right? Because I don't think there's a neural voice isn't a feature of the real time, right? I think that's just of Azure Speech.
No,
okay.
I believe so.
Yeah, so I think let me find this docs for that. So that's something you can do. Like you can actually like train it. I was reading those actually yesterday, and I was like, ooh, this is cool. I might want to do this. It does say there's an intake form. So yeah, it does say there's still an intake form. So it sounds like you have to fill out the forms. Sorry, but maybe it's worth it, because imagine getting to have a voice. I think one of my colleagues did it and has been like testing out making videos with their voice. I'm super curious what my voice would sound like. I think this is all really interesting, because in college my research was into like facial animation and like being able to like generate kind of avatars on demand. So it's really cool to see how it's getting better and better.
Yeah. Actually, I've noticed from playing with the real-time audio model that it will reply with a different intonation or tone depending on how you ask the questions. So if you're like very upbeat, it will probably reply to you in an upbeat way. But if you're kind of down, it happened to me when I was doing the demo like many times. I was tired and I was asking the questions like, "Oh, come on, tell me something," and it would reply to me in the same tone. So yeah, if you play with it, you may be surprised.
Yeah, I did find that actually now in the Azure Speech text-to-speech voices, you can select from different emotions. Like the ones I saw had empathetic and relieved. And it was really interesting to try out like empathetic and relieved. I still don't think I would use them for a RAG application, but I could imagine wanting to turn those on in certain cases. Like if you had like a sentiment analysis tool, then you might be like turning on the empathetic. But it sounds like, I mean, this is two different APIs, right? It sounds like the real-time API is already just like changing its emotion on demand, different from the Azure Speech SDK where you control the emotion via parameters. So here we do have some more real-time resources for those of you who want to dig in. Enrique put this list together. You can click these links from the slides, but we're also just pasting them in the chat so that you can follow them there. So it's just a bunch of more real-time ones. So just bookmark those if you're digging into real-time API. It's really cool. It's really interesting. And even though I've even been in that VoiceRAG code base myself, I still need to understand it just a little better because there's a lot going on there, right? Like there's the WebSockets, there's the, all the real-time stuff. So I think this is really new and exciting technology. For next steps, do join us for an upcoming session. Try out our repo. I have office hours on Thursdays in Discord. This week it's going to be at 1:30 p.m. PT instead of 12:30 because I also have another live stream at 12, which you should come to. So you can come to those Discord office hours if you want to ask more questions about any of this stuff or play around with stuff. If nobody asks questions, I'll just be sitting there deploying DeepSeek and having fun with it. So come along. And we also have this resource that has more RAG resources. So you just sign up with your email and then you can get a bunch more RAG resources here. And that is our session for today. And I hope you learned a lot. I did. Thank you, Enrique, so much for joining us today.
Yeah, thank you, Pamela. Thank you, folks. Happy to be here.
Bye, everyone.
Bye-bye.
Thank you, everyone, for joining. Thank you to our speakers. This session is a part of a series. If you'd like to watch previous episodes on demand or register for future shows, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. Today's event code is 24576, and we will see you at the next one.